This is a brief presentation of our solar system. A more detailed presentation with more info about the planets is located on my website under the astronomy page in ESS. We all know that Pluto used to be considered a planet but now has been demoted to a dwarf planet. We will address this later in the presentation. The theory of how our solar system began is called the solar nebular theory. When stars live and die, nebula are formed, and when these nebula are in existence in the universe, gravity will pull the matter together to the center. The star ignites at this point in the center, and over billions of years, when the star becomes a main sequence, the gravity of that star then allows for planets to start orbiting. The matter collects because of gravity, protoplanets are formed, and then as evolution of the solar system continues, we see the planets and moons we have in our solar system today. The matter that gathered together for those planetismals, some of them still exist in our solar system in different parts, known as the asteroid belt, the Kuiper belt, and the Oort cloud. But once the seeds become about 1 kilometer in size, they have enough gravity to begin collecting more matter to become a larger planet. Then as the planet becomes larger and larger, it will attract more matter, and sometimes that's how moons are captured in orbit, such as with Jupiter and Saturn. The leftover matter we theorized was what was pushed out to the outer regions of our solar system. Here's a diagram briefly illustrating the evolution of a solar system such as ours from a nebula. So the disk collapses, becomes circular, the star eventually ignites at the center, the planetismals are orbiting around the star, and then eventually form the larger planets and moons. As a reminder, in our solar system, we use what's called the astronomical unit. It is the baseline unit of the distance between the Earth and the Sun, which is 93 million miles. Since our solar system's too small to have a light year being applied, we use the AU. Our Sun is the most essential part of our solar system, and it contains most of the mass. 99.85% of our solar system's mass is contained in the Sun. Our Sun, as we studied before, is halfway through its life, and it is a main sequence star and is a medium mass star, so that means it will never explode. The Sun is about 1 AU from us. It takes about 8 minutes for the light from the Sun to reach Earth. As we studied after the test, there are two sets of planets in our solar system, the inner planets and outer planets. The inner planets are composed of Mercury, Venus, Earth, and Mars, and the outer planets are composed of Jupiter, Saturn, Neptune, and Uranus. Each of these different sets of planet classifications have their characteristics that are common within that group. With the inner planets, they are known as the terrestrial planets because they actually have a solid surface. They have few or no moons. The outer planets are known as gas giants, and they're located beyond the asteroid belt. And they're also known as Jovian planets, named after Jupiter. All of the outer planets have rings and have a lot of moons. The asteroid belt, located between Mars and Jupiter, is the defining boundary between the inner and outer planets. A lot of large rocky bodies are orbiting in this region. The largest is Ceres, with a length of 1,000 kilometers, to the smallest, which are no larger than pebbles. Some of these have orbits inside of Earth, and others have orbits as far out as Saturn. Some orbits cross paths with Earth and have collisions, such as the crater in Arizona. These asteroids are believed to be remnants of the formation of our solar system and got trapped between the gravity of Mars and Jupiter in this region. Some of this may have been matter that did not become part of a planet. As we stated earlier, Pluto was demoted in 2006 when they reclassified what a planet is. A planet large enough, has enough gravity to be a sphere, has its own independent orbit, are two of the classifications of what a planet now is supposed to be. However, our classification of Pluto has changed because of the new criteria. Pluto's orbit is very elliptical, and it actually crosses paths and overlaps Neptune's orbit. And also, Pluto is by far not the largest thing in its neighborhood, so therefore it cannot be its own planet. The Kuiper belt has many objects that are larger than Pluto, and the Kuiper belt is where Pluto currently resides. You can see in this diagram of Pluto and its moon, they can fit inside the United States. The picture above is actual telescope image of Pluto and Charon. Dwarf planets are objects that have neither a moon, that are not classified as neither a moon or an object. They do orbit the sun and they have enough gravity to be considered a sphere, such as with Pluto. They again are not large enough to be the biggest thing in their neighborhood. These dwarf planets do overlap the orbits of other planets. Here are some examples of dwarf planets within our solar system. This is a comparison of Pluto with Earth and our moon to scale. Here is a chart of different dwarf planets in our solar system and how they compare to the moon. And so you can see that even our moon is far bigger than a lot of these dwarf planets located in our solar system. As we go past Neptune, we encounter what's known as the Kuiper Belt. The Kuiper Belt is a region of asteroids and near comets that were pushed out by the gravity of Saturn and Jupiter. The Kuiper Belt is about 60 AU away from the Sun and is 200 AU across. Again, astronomers believe that the short-term comets come from this region of the solar system. The probe New Horizons is exploring this region at this time. The Oort cloud extends far beyond the Kuiper Belt. These are again, objects that did not become part of the planets of the solar system and were pushed way out to the boundaries of our solar system. The Oort cloud is actually past the heliosphere, which is the region of the solar system in which the sun has influence with its gravity. A lot of the objects in the Oort cloud are icy objects, but again, comets, long-term comets, long-range comets, asteroids, and meteors. It is about 190,000 AU away from Earth. Again, this is beyond the heliosphere or under the influence of the sun's gravity. And in this diagram, you can see where these different objects fall in place in our solar system and just how far the Kuiper Belt and Oort cloud are in reference to the sun. This diagram also notes where Voyagers are located, which we will be discussing in just a moment. Voyagers 1 and 2 were launched in 1977. Their missions were to explore Saturn and Jupiter and their moons. This is an image of Voyager 1. This is an image from when Voyager 1 was passing by Jupiter. And another which located an explosion from one of the volcanoes of Io. Voyager 2, also launched in 1977, is actually moving faster than Voyager 1 and passed it. This probe was sent to take pictures of Jupiter, Saturn, Uranus, and Neptune. This is the only probe to visit and take pictures of Uranus and Neptune. It was thought that these probes would not have enough energy to continue their journey, but when they saw they had enough fuel to continue, they let both Voyagers continue to see if we could get them out of our solar system and transmit information about the outer regions of our solar system. At this point, they have reached the Oort cloud and are moving beyond the Oort cloud, making them the first objects to actually be outside of our solar system. So these are images taken from Voyager 2. So here's Uranus as seen from Voyager 2 in the 70s. Neptune. And these are the clouds on Neptune, which supports the theory that there are storms on Neptune just like there are on Jupiter.